Welcome back. We are discussing about the wastewater treatment operations, under which in this video we will be talking about the sludge handling aspects, in particular sludge drying beds. The sludge drying beds mainly they are used for drying of digested sludge or raw sludge on open beds of land. And usually the sludge which is collected from primary and secondary sedimentation tanks, it will be passed through an anaerobic digester, and the digested sludge is to be disposed of onto the sludge drying beds for drying and dewatering. But occasionally what will happen is the people who cannot afford to having a sludge digester, they can directly send the primary or secondary sludge directly onto the sludge drying beds. It is nothing in this sludge drying beds. The basic operation is mainly the filtering action. Here we are having a sand bed and then supported by gravel or broken stones. Then preferably gravel is used, and the sludge is spread on top of the sand. Sludge contains no water and solids. The water will get filtered through the filter medium which is there at the bottom. And the filtrate, the liquid is collected at the bottom through the sloping portion of the bottom here. And the solids which are there on the top, they will be dried out in the open sun. And then this filtrate is collected and then disposed of separately back into the treatment system. Usually the sludge is distributed through a distribution channel where it can be operated into either of these beds which are parallelly operated. Now you can see a small image here where we are having a number of parallel beds. Here the sludge is now spread out onto these beds using a wall system here. By opening this wall, you can see this is how the sludge is coming in, and then by opening this wall, this sludge will flow into the sludge drying bed. It is not directly allowed to enter into the sludge drying bed. We are keeping a splash pad here, and to prevent any damage or potholes onto the bed or the sludge beds. Here we are going to keep a longitudinal slope so that whatever the sludge which we are disposing it here into the tank, to the bed, will flow across the entire length of the bed. Now what you see in this is after the entire water is dried out, the sludge which is now evaporated and dried in the form of cakes. These cakes can be scrapped out and sent out for its usage. Now you'll see the construction of the sludge drying beds. The sludge drying beds are open beds of land 60 to 90 centimeter deep. So this is the total depth, sludge plus sand plus gravel, consisting of 30 to 40 centimeter gravel or crushed stone with 20 to 30 centimeters of sand above the gravel. The sludge of 10 to 30 centimeters is spread on the sand and through the distribution troughs. These are distribution troughs. Now in this picture you see the sizing of the sludge bed. Compared to the previous photograph, what we have seen, they are having small size of such beds. Here we are having quite a long beds and then quite a sufficient width also. So that's why we are calling as usually there are 10 meters by 30 meters in plan, and the length normally kept around 30 meters. And there will be a longitudinal slope, very small amount of slope is provided. So the entire water is now filtered out in the longitudinal slope like this. And it is collected from the bottom section of the drainage pipes which are provided at the bottom of the bed. So these beds are surrounded by brick walls rising 1 meter above the sand surface. You can see in the elevation here, this is small portion is rising. And here also in the photograph, you can see some small portion is rising above the top level of the bed. So that why you're doing it is again when there is a flooding on the ground, it should not fall into the sludge drying beds. The runoff should not fall onto the sludge drying beds. In operation, sludge is spread on the sand beds over a shallow depth of 10 to 30 centimeters. This helps in drying a sludge in sunlight. So mainly sunlight is the major medium of drying of this sludge. A small portion of the moisture in the sludge is evaporated while remaining is filtered through the bed. The filtrate is normally recycled back into the aeration tank as the BOD content will be high. We cannot dispose this filtrate, so we can go back into the aeration tank. Under Indian conditions, if you see, the beds normally take 2 to 3 weeks to filter the moisture from the sludge, and around 1 week is kept for opening of the bed and making ready for next cycle. This is the maintenance activities. The usually we see here in this, you can see in this bed, these two are different and this is different. What is the meaning of this? These two are in operation. This is now under maintenance. What is the maintenance here? After the entire sludge is dried out, the top portion is scraped off, and now the voids, whatever there on the sand bed, they might have got clogged. So then they will be opened up. They opened up and then is allowed to dry so that if still some moisture is still remaining in the voids of the sand, then they will also be dried out in the atmosphere. That is the reason of opening of the bed during maintenance operation. That's the reason why normally we try to go for parallel operation of the beds, and also we try to keep at least two beds as a standby units so that these two extra filter sands, SDBs or dry beds, they will help in doing the maintenance works when required for the regular sludge drying beds, such that at any given time, the designed number of sludge dry beds will be under operation. Let's quickly look at a small problem. Design a sludge drying bed for 500 kgs per day of sludge with a moisture content of 95% and specific gravity of 1.05. Assume suitable values. When the moisture content is 95% means solids content will be 5%, because solids plus water will be 100%. Volume of the sludge we can calculate using the formula dry weight of the sludge divided by specific gravity of the sludge into 1000, converting into density and percentage solids. So now if you put this formula here, dry weight is given as 500 kg per day, and 1000 into 1.05 is the specific gravity. 5% means 5 by 100. It comes out to be 9.52 meter cube per day. So per year, it will be around 3476 meter cube. So now let us make a quick estimation of number of operational cycles per year. Assuming that in Indian conditions, around 2 weeks of operation is there for filtration, and then 1 week you can go for drying. Total 3 weeks is there, drying as well as the repairs. So number of weeks in the year are 52. So suppose we neglect the rainy season 2 months, so there's no such operation. So available number of weeks are 52 minus 8, 44. So 2 months means 8 weeks. So number of effective cycles per year will be 44 divided by 3 week per cycle, which is around 15 cycles we can operate. Now let us assume a 30 centimeter depth of sludge application. So we have seen that earlier it is 10 to 30 centimeter depth of application. Area required will be equal to volume per drying period divided by depth. So let us assume 15 days or 2 weeks is the dry period where drying and filtering is taking place. So area required will be equal to 9.52 meter cube per day. This is the volume of the sludge coming, and multiplied by the number of days of operation and divided by the depth of sludge application is going to give you the floor area of the sludge drying beds. 476 meters square. Meters square. So now what we are calculating is, let us assume the surface area of the bed as 10 meters by 12 meters. So each bed is having 10-meter width and 12-meter long. So area of each bed will be 120 meters square. Total area required is 476 meters square. So how many beds are required? So you are having 4. As I mentioned, we should have another at least 2 beds extra. So we will provide +2, so that at any point of time, 2 beds will be under operation, 2 beds will be extra, and 4 beds will be under operation. And usually we have to provide some space for creating the path, and then internal arrangement, piping arrangement, and then channel arrangement, partition walls, etc., etc. Suppose we keep around 50% extra area as allowance. The total area required is 714 meters square, but effective area is only 476 meters square. So here even number is provided for parallel operations, so that 2 beds extra provided for cleaning, drying, and maintenance, so that anytime 4 beds are in operation, the drying period and the cleaning of the bed and all those things will be taken care by these 2 extra beds which are provided in the SDB. So now we are talking about this particular dried portion of the sludge. What we have to do with this sludge cake? So you can see here, this is totally dried. You can see totally dried here, because the sewage is now passing through this filter bed. The whatever the nutrients are there, they are now retained on the sand in the form of nutrient material as a sludge cake. The sludge after drying is removed by scraping and used as soil conditioner because of the nutrient contents in it. Or it can also be used as a fertilizer in the agricultural lands. And it contains a 1.7 nitrogen, 1.5% phosphoric acid, and 0.5% potash, which are utilized. These are the usual values which we obtain from a domestic sewage sludge after drying in the sludge drying bed. Otherwise, the scrap dried sludge is filled in low-lying areas. So if it is not the usage of the sludge in the form of agriculture, we can go for filling in the low-lying areas. The sludge from industrial waste often contains hazardous chemical and hence is filled in a pit or burned up by incineration. So it should not cause any impact on the environment. So they should be completely filled in a lined pit and then closed. So this way, the moisture is reduced from the sludge, so that volume of handling will be improved, and whatever the liquid is coming out, it is not sent into the atmosphere, it is sent back into the treatment system. So the sludge drying beds are the most widely used sludge handling systems in the wastewater treatment or sewage treatment. Okay, thank you.